Every year, more than 10 billion square meters of plasterboard are produced worldwide, enough to cover millions of homes from the United States to Europe. This seemingly simple material has become the true backbone of modern construction. Yet the journey that transforms raw minerals into the flat walls we see every day hides an incredibly complex industrial process. In this video, we take you inside massive factories to discover how millions of sheets of drywall are made and why it's become the #1 choice in construction around the world. Over 95% of homes in the United States use drywall for their walls and ceilings, making it the most common material in residential construction. Each board consists of a core of ground gypsum powder pressed between 2 layers of heavy-duty industrial paper. This mixture produces lightweight, fire-resistant panels that offer superior sound insulation to many traditional materials. In the United States, a standard 4-foot by 8-foot board costs about $10 to $20. Although the initial cost is slightly higher than that of simple wood or plastic panels, its quick installation and low maintenance make it a worthwhile investment in the long run. The first step in manufacturing gypsum board involves extracting gypsum from gigantic mountain ranges, where the mineral lies deep and is only accessible through vast open-pit mines. Powerful drills bore holes several dozen meters deep, creating shafts strong enough to accommodate explosives. Specially designed mining charges are placed deep within the rock so that, upon detonation, entire layers of gypsum are detached from the mountain. With these carefully calculated blasts, the ore is freed and ready for the next stage of its journey, becoming an essential material for modern construction. Then, as soon as the signal is given by the chief supervisor, the explosion is triggered, projecting thousands of tons of gypsum from the face. Huge excavators approach the freshly detached piles of gypsum and remove blocks weighing several tons at a time. Each machine works in step, loading the material into the backs of smaller, specialized trucks. These trucks roll along dusty tracks, transporting the gypsum to a temporary staging area. There, the loads are transferred once again, this time into large, heavy-duty conveyors designed to transport large volumes. From this point, the gypsum begins its journey to the processing plant, where the rough stone will be transformed into useful construction material. Trucks loaded with gypsum rock regularly arrive at the plant's receiving area. Each truck can carry several dozen tons and discharges directly into a large stockpile located right next to the main processing line. On-site engineers record volumes and manage the distribution of raw material, preparing it for the first stage, crushing. On average, this facility receives and processes more than 100 trucks per day, representing thousands of tons of raw gypsum entering the production flow. Next, excavators move into the storage area to remove huge quantities of rock and dump them into the chain's feed hopper. From there, the large blocks are fed to huge crushers. This crushing phase reduces the rocks into smaller fragments, facilitating the subsequent drying process. The gypsum crusher operates with 2 massive rollers that rotate continuously, exerting strong pressure on the incoming rocks. Large blocks are gripped and then fragmented into smaller pieces under the force distributed over the roller's surface. Thanks to this continuous movement, crushing energy is used efficiently, making size reduction more efficient. The result is a continuous stream of crushed gypsum flowing out from the bottom. These gypsum rocks can contain 70 to 80% pure gypsum and are crushed to particles only a few millimeters in size. However, this process generates a huge amount of dust. If workers lay for long periods, it can lead to serious illnesses such as lung cancer. Once crushed, the gypsum is transported on huge conveyor belts that extend deep into the factory. These belts are hundreds of meters long and rotate continuously at a steady pace to maintain an uninterrupted flow of material. Thanks to this automated conveying system, each gypsum particle is transported directly to the drying and processing area for the next step. After grinding, the fine gypsum powder is conveyed into a giant rotary kiln for the heating stage. During this phase, the hydrated calcium sulfate gradually loses its water and transforms into calcium sulfate hemidrate, commonly known as calcined gypsum. The burner flames are projected directly into the furnace, creating temperatures that vary from about 300 degrees Celsius to over 660 degrees Celsius, with some hot spots reaching nearly 700 degrees Celsius. Heating typically lasts several hours, allowing the water to slowly release so that the crystalline structure does not degrade too quickly. Engineers carefully monitor and adjust the controls, maintaining stable temperatures in different areas of the furnace. This strict control produces high-quality gypsum powder, ready for the mixing stage. Once heating is complete, the gypsum powder is sent to the mixing room for final preparation. Before mixing the entire batch, technicians take a small sample for the laboratory for testing. There, the powder is mixed with water at a precise ratio and combined with additives such as starch or setting time modifiers. The mixture is vigorously stirred and then monitored for expansion, strength, and setting time. The results are compared to required quality standards, helping engineers confirm the stability of each production batch. This control step ensures that the gypsum intended for mass production always meets the highest level of reliability. Once the formula is validated, the automated system begins mixing the gypsum powder with water and additives in the exact proportions. Each batch of raw material quickly transforms into a thick slurry, ready for the next step: molding. Plasterboard isn't just made of gypsum powder. It's firmly sandwiched between two layers of cardboard, which strengthens the board and prevents warping. That's why huge rolls of paper, stretching hundreds of meters, are continuously fed into the production line. Specialized machines carefully unroll and smooth the paper, keeping the surface wrinkle-free. Operators remain vigilant, adjusting speed and tension to ensure the paper aligns perfectly with the line. This layer serves as a critical structure, providing a solid foundation for the gypsum to bond to and form a complete panel. Immediately afterward, the gypsum slurry is sprayed at high power onto the flattened paper surface. High-speed nozzles distribute the slurry evenly, forming a continuous, even layer. This allows the gypsum core to firmly adhere to the paper, laying the foundation for a complete plasterboard panel. Next, the layer of gypsum slurry deposited on the paper passes under a system of massive rollers to set its precise thickness. These rollers are designed to rotate continuously at a stable speed, exerting light pressure on the surface of the mixture. With controlled pressure and great precision, the gypsum layer is leveled evenly from edge to edge. The thickness of a plasterboard sheet typically ranges from 9 to 15 millimeters, depending on the type of product manufactured by the factory. This step ensures that each panel coming off the line has consistent dimensions, ready to meet the demands of modern construction. Immediately after the gypsum layer has been leveled, an automated spraying system sprays a fine solution onto the surface. This coating eliminates air microbubbles that form during mixing and spreading. If left untreated, these microbubbles could create cavities and weaken the panel. The solution is usually clean, filtered water, sometimes mixed with additives to improve adhesion. The droplets are ultra-fine and evenly distributed, without distorting or disturbing the panel during shaping. Thanks to this controlled spraying, the product maintains a uniform structure and a smoother surface. After this, the edges of the panel are precisely shaped by specialized machines, creating clean and regular contours. This operation produces clean edges, facilitating assembly and installation on construction sites. Once the panel is fully formed on the conveyor, it enters the automatic cutting area. There, sensors precisely measure the length of each panel and send signals so that the industrial blades fall in perfect synchronization. The sharp blades operate continuously, cutting the panels into standard sizes, such as 2.4 meters or 3 meters, depending on production needs. The cutting speed is carefully calibrated to avoid cracks or surface slippage. Then each panel is separated and neatly arranged on the conveyor to move on to the next step. Thanks to this advanced cutting system, the final product always meets consistent quality standards. The next step is crucial. Each panel is folded so that the wrapping paper tightly grips the gypsum core inside. The mechanical system uses lifting arms and automatic guides to fold the moving sheet with great precision. When the paper folds, it forms a solid shell that holds the gypsum in place and protects the surface from cracks. Without this layer of paper, the gypsum crumbles very easily, making transport and installation difficult. At the same time, the paper creates a smooth finish that makes painting or tiling easier. This folding process gives the panels the strength and crisp appearance they need before being put on the market. Afterward, the panels are transferred to a massive drying chamber to remove any residual moisture from the core. Inside, the temperature is maintained between approximately 300 degrees Celsius and over 660 degrees Celsius, depending on the stage, and each drying cycle lasts around 30 minutes. Hot air is distributed evenly across all levels, ensuring that each panel dries evenly from the inside out. This stage gives the plasterboard the necessary hardness and strength before the final finish. Once the panels are dry and stabilized, they move on to the edge sealing line. Machines apply special paper strips along the sides of each panel, protecting them and strengthening their strength. The paper rolls are pre-printed with logos, product details, and technical specifications, and rotate continuously to maintain production consistency. This process not only prevents edge warping during transport, but also provides clear brand recognition. Forklifts transport stacks of finished panels to the storage area, where they are neatly stacked in high blocks. This system allows thousands of panels to be efficiently stored, ready to fulfill large orders. Well-organized storage also speeds up and secures loading operations. When an order arrives, forklifts load each batch of panels onto specialized trucks. From there, the fleet leaves the factory to transport the panels to construction sites and market distributors. Once they leave the factory, the sheets are easy to install, lightweight, durable, and quick to work with. In the United States, over 90% of homes now use drywall for interior walls and ceilings. The cost is also affordable, at only a few dollars for a standard sheet, making it a popular choice. Its convenience and cost-effectiveness have made drywall an almost indispensable material in modern construction. If you like this documentary, don't forget to like it, subscribe, and activate the bell so you don't miss any of our content. But don't leave yet, there's more. The rest of this video will be just as exciting, so stay tuned until the end.
These logs you see on screen are not ordinary wood. Each one was cut with millimeter precision and transported from certified forests for a single purpose: to transform it into plywood, one of the most versatile and durable materials we use every day. From the furniture in your home to concert stages, roofs, floors, and even some boats. It all starts here. But how do you go from a rough, solid log to a smooth, lightweight plank that's as strong as steel? To understand this, we need to go back a little. The idea of plywood isn't new. It originated in the 16th century as an ingenious solution to better exploit wood and prevent it from warping over time. And it worked so well that today, more than 160 million cubic meters of it are produced worldwide each year. Now, let's get down to business. The first step when these logs arrive at the factory is to remove their bark. This isn't just for aesthetics, but also to avoid residue and ensure consistent cutting. Then, the trunks are cut into easier-to-handle pieces, like enormous wooden sausages. This is where things get fascinating. Each section is immersed in huge pools filled with water heated to over 60 degrees. Not to clean them, but to soften them. Because if you want to unroll a trunk like a roll of paper, it must be soft and pliable. After several hours, the trunks are ready for what many consider the most hypnotic part of the process. Enter a machine that looks like it came straight out of a science fiction movie. The rotary uncoiler. Imagine a tree trunk spinning at high speed, while a blade slices it from the outside in, as if you were peeling an apple without ever stopping. From this trunk springs an endless ribbon of wood, as thin as a sheet of paper, but continuous as if extracted directly from its heart. Each trunk can provide tens of meters of leaves, but these, in their current state, are not yet usable. They are damp, curved, and often have defects. The next step is a passage through a huge heating tunnel. Literally, a giant structure where the leaves circulate on a conveyor belt, while a flow of hot air gradually removes the moisture. The goal isn't to make them dry as cardboard, but to find a right balance, maintaining a certain flexibility without them bending on their own. Upon leaving the kiln, each sheet is inspected, sometimes by an operator, sometimes by an automated scanner, depending on the factory. If stains, severe knots, or cracks are detected, they're discarded or cut into smaller pieces for other uses. Only the best ones advance to the next stage. Why so many requirements? Because the strength of plywood depends on each of its layers. If one is defective, the entire panel loses its strength. Then comes the crucial step, gluing. This isn't your average white DIY glue, but an industrial adhesive designed to withstand pressure, moisture, heat, and decades of use. One machine applies the glue like a gigantic inkjet printer, while another stacks the sheets in a very precise order. One with the fibers horizontal, the other vertical, then horizontal again, and so on until a sandwich of 3, 5, or even 9 layers is formed. This crossing of the fibers is the key to plywood strength. It doesn't bend easily, doesn't splinter like a regular board, and can withstand weight and tension from any angle. But for now, it's still just a damp, sticky pile of overlapping sheets. The real magic is about to happen. The transformation of that sandwich into a single, solid, flat block capable of supporting anything. This is where the metamorphosis occurs. This sandwich of glued sheets is fed into a giant hydraulic press. The goal? To apply several tons of pressure and extremely high temperatures for several minutes. The heat activates the adhesive and allows the fibers to intertwine. What were once separate layers are then welded into a single piece, as if they had always been united. As soon as it comes off the press, the result already closely resembles the final product, a sturdy, solid, and ready-to-use plywood board. But that's not all. The next step is cutting. Large, compressed sheets have uneven edges and excess material. An automatic saw cuts them with millimeter precision to the desired dimensions. Large panels for construction, smaller formats for furniture, or even custom cuts for specific orders. Then comes the sanding. Here, huge abrasive belts, comparable to industrial-grade Vermet sandpaper, polish both sides of the boards until they are as smooth as a freshly waxed table. This not only serves aesthetics, but also ensures a perfect fit when they're used for walls, doors, or furniture. As the boards move along the production line, they are rigorously inspected. Laser sensors check the thickness, detecting any internal bubbles or poorly pressed areas. If a board fails the test, it is immediately discarded. Those that pass proceed to the special treatment stage. Depending on their intended use, they can be protected against fire, moisture, or even insects. Some are impregnated with a special resin. Others are coated with varnish or even melamine, the hard plastic that gives the glossy white finish found in much modern furniture. This step transforms a simple board into a surface capable of withstanding years of daily use. Then comes the packaging. The finished boards are grouped into batches, carefully stacked, and wrapped in protective film. Each batch bears a label detailing the date, with species, glue type, treatments applied, and final destination. Some go to DIY stores, others to construction companies, but all are digitally tracked to know exactly where they are and what project they're intended for. And if you're still wondering why this material is so popular, the answer is simple: its versatility. A single sheet of plywood can become a kitchen cabinet, a base for a floating floor, a structural element for a roof, or even part of an airplane cabin. Yes, it's that reliable. In fact, you probably see it more often than you think. In that partition wall in a shopping mall, on the stage at a concert, or at the coffee shop counter where you get your morning drink. Plywood is everywhere because it combines the best of wood with the best of engineering. And to think it all started with a spinning log and a blade that peeled it like a ham. This is how wood became a tool for building the modern world, layer upon layer. If this process surprised you, subscribe, leave a like, and tell me in the comments what other materials you'd like to discover. Because here, I'm revealing how things are made like you've never seen them before.